11?
12.
11, yes, yes, yes. It flowed for 82 days this way. So we don't want to, and the company, operating company lost many billions of dollars. So we don't want to take this and we lose our resources. So we have the risk on the humans, right? On the humans, we can lose the lives. We can have risk on the environment, right? Pollution, burning of gas, oil, like this. We have also the assets. We can also lose the assets. The rig, the well, the stations, all of this. We can lose the company reputation also, right? If this company has any incident, then all companies will know that this company has incident and don't go to it, don't give them new contracts, and so on. So we have procedures. It was suggested by IOGP. You know IOGP? International Oil and Gas Producers, right? Or Association of Oil and Gas Producers. So this directed the corporates which are IWCF in UK and IADC in USA to improve their procedures, to avoid any gap, anything that could lead to an incident for oil and gas wells, in addition to stations, to all of this. So here we are to improve ourselves. I know you may have done this course many times. How many times you did it, Mr. Srinath?
This is my third time.
Third time. And Mr. Muhammad?
This is my first time.
First time. So, but I think you have at least 10 years, right? Both of you, or more, 20 years.
10 years.
10 years. Mr. Sritan? Huh?
13.
MashaAllah, you see? So we are here just to give you my experience and you give me your experience. Anyway, here well control incidents after drilling operations have concluded and the rig has been moved off location. It is up to production because when we move as a rig, we hand the well over to whom? To operation, right? Or to production engineering. Well servicing and work over personnel to maintain the integrity of the well till the end of the well. The well life cycle. You know the well life cycle? This is the well life cycle. You know it? We start from the design phase, basic of design phase, then we execute or construction phase, then we go to operation, then to intervention, which is our phase. This is our phase, intervention, including what? Wireline, coil tubing, snubbing, and workover, right? 4. We have well testing, it is included in it. Till the end of the well life cycle, we call it plug and abandonment. So this plug and abandonment, as if a man has died. What shall you do? You have to bury him, right? So here is where to bury the well, oil and gas well. We call it plug and abandonment phase. So all of these we have to so who can remind me, why do we do well control? Why? Now the summary in one word, please.
Reduce the hydrocarbons in a safe manner.
Like this. You told me a golden rule. This is just to protect ourselves, to protect the environment, to protect the asset, the equipment, the company reputation, all of this. So we don't want incident. Our target is how many incidents per year?
0.
Excellent. 0 incident. So we want to do like this. So systemic risk management. What is the definition of the risk? You know the risk and hazard? What is the difference between hazard and risk? hazard, we have 6 types of hazards, right? We have mechanical, chemical, electrical, environmental, administrative, all of these we have types of hazards. And we have risk. So what is the relation between hazard and risk? I will tell you an example. I have a car. The car itself, it is hazard or not? It is hazard. When I drive it and go from Muscat to Dubai at 200 kilometers per hour, is it hazard? Is it risk or not? The rollover may happen or not? Rollover may happen. So the hazard, the risk may be high if I die, maybe medium if my my hand or leg has broken, there is minor risk, minor damage, right? If I do like this, so it is minor. So the risk may be high, medium, or low in relative to the hazard. I will tell you another example. You have knife in the kitchen. It is hazard or not? Mechanical hazard, or what do you call it? Any hazard. If a small child came to the kitchen and took this knife and do like this on his hand, is it risk or not? Risk. So this risk may be high or medium or low. I have swimming pool. You know swimming pool? It is closed. Nobody is swimming there. It is hazard by itself. But if a small boy came, sink down and didn't get out, what do you call it?
Risk.
Risk, yes. So the risk, we have an equation. If you write it down with you, please. Risk equals probability times consequences. You write it down, Mr. Muhammad, please. Risk.
You have another pen. This pen, it doesn't like.
Yes, please.
Probabilities cross consequences.
Yeah, exactly. So risk equals, it is an equation. Probability probability times consequences. A probability could be medium, high and low. High, medium and low. Also the consequences may be low, medium and high. So is it clear for you, Mr. Srinath now?
Yeah.
Very nice. Yes, Mr. Muhammad, if you write it down, please. The risk equals, it is an equation. Risk equals probability or possibility times consequences.
Times consequences. Huh?
Yes, consequences. So we use something we call it risk assessment matrix. It is 5 by 5. You use it or not?
Nah.
But I will explain to you. No problem. You will be very familiar with it. So 5 by 5. This x means probability. This y consequences. So this x we have to put numbers 1, 2, 3, 4, 5, right? And y you have to put 1, 2, 3, 4, 5. So as you go up, the consequences will go up, right? And if you go here from 0 to 1, 2, 3, 4, 5, the probability will be higher, right? So when you go in this side, high probability and high consequence, the risk will be high or low if you go up. It will increase, very nice, it will increase. So we try to reduce the risk. How? By putting controls. I will tell you, if you have a station and if you want to do protection or prevention system, how can you put the prevention system? You have to put fire extinguishers, fire truck, fire hose, warning signs, fence, blah blah blah, all of this. In addition, you have to teach the people how to control the fire, so all of this is we call it controls, right? So if you increase the controls in a logic manner, then you can reduce the risk from high to medium or from medium to low, because the risk you cannot avoid it 100%. Okay, we have to reduce the risk from high to medium or from medium to low. So we have in this risk management, we have this circle. If you look at it, please. First, you have to identify what is the risk. The risk is the car, for example. And may I have a problem in the car, may I have an incident, I have a rollover. Then I have to evaluate, what if I change the tires? What if I improve my abilities and do refreshment for driving, defensive driving code? What if I change the mirror, if I do maintenance for the car? All of this evaluation. Then we have prioritization. If I go through this road, it is good, and there are no holes on the road. If I go in this road, there up down. So then assessment. After all of these, do you see that the risk high and you can reduce it to medium, or medium can reduce it to low, and so on. Then elimination. If I want to not to go in my car, go in the bus, or to go with minibus or like this, you can eliminate this risk, and so on. This we have continual improvement. Always we improve ourselves by continual improvement. Every day, every time we improve ourselves. So in this case, management of a change. Now you tell me, we call it MOC. You heard about it or not?
Yes.
Very nice. Now, I am a company man, and I give you, Mr. Srinath, go to this well. I am from video. Go to this well and do drift run. And when you take the program, you tell me, please, my friend, this subject is not included here in the program. This. So the program is not 100% perfect. What shall I do? You give me the program. I go to my administration and discuss with the engineer who issued the program. And he will discuss with his team leader. Team leader may discuss with manager. Manager may discuss with the CEO, and so on. So you stop as a service supervisor or engineer, and you wait for the action from the PDO or ADCO or Aramco or whatever, just to change or do this management of a change. What does it mean, management of a change? This we have to add what is missing to the program. The crane is 50 feet or high, but we have in the program it is just 20 feet, so we can change it. This. So all of these we can change them. For example, the Christmas tree is 5K, but you mentioned it is a 3K. What is it? So I cannot accept. So all of these should be modified. And who signed on the program? Engineer, team leader, who else? Manager and CEO. All of them should sign on the new program, or we modified it. Then we have to scan it and send it to all involved people who should know what happened. We are not working secretly, right? We are working in a company, teamwork. If you want to work and hide what are you working from your friend or colleague, the life will not go on, right? So we have to do this one and avoid any gap or any incident that could happen for our company and our operations. In this case, you receive the program, maybe your manager will receive it by email and so on. Now you will cover all gaps that could have happened whether you don't pay attention, whether the company man doesn't pay attention, but now you are working very well and you protect yourself, your company, your colleagues from any upcoming incident or upcoming risk, whether this risk high or medium or low. and you are working as per procedures that were put by the company. Any question about management of a change, my friends? Very nice, very nice. Why you understand? Because you are working the same, right? This happened with some of you or not?
Yes.
Tell me please, tell me the example from your side, Mr. Muhammad.
From my side, if you said, I wanted to set a plug many times above the nipple.
Yes.
They wanted above the nipple, but there is tubing collapse or damage in the tubing, so they will need an MOC to set the plug as a barrier shallow.
Mm-hmm. Yes. What happened?
The MOC takes like the management works in the morning, so it takes a lot of time till we get the MOC.
Discussion. What's your
Yeah,
opinion?
they have a morning meeting by 8. So if we're doing the job around 20 at night,
Oh.
8 o'clock at night.
Oh.
So you'll have to wait
How many?
12 hours.
How many hours? 8 hours or more.
Until next morning, 8 o'clock.
Oh.
They will do the meeting, and then within 1 hour, maybe they will get the MOC.
This is called management of change, right?
Yes.
Because you see something it is not in the plan, right? It is not foreseen. Very nice. You have another example, Mr. Spinat, or not?
Yes, there is an example. We were planning to set a packer, and the well pressure was 4,000 psi,
Mm-hmm.
and the packer setting pressure was also 4,000 psi differential. So on surface, we will need 8,000 psi to set the packer.
Oh,
This
8,000.
was not covered in the well program,
Mm-hmm.
and the company decided to bleed off some of the gas pressure to 2,000 psi to make that packer setting pressure of 6,000 psi.
Mm-hmm.
So an MOC was created for that.
Very nice. I have an example in Abu Dhabi. We were having a logging operation, and we have to run the logging tool string. But the wellhead pressure was 4,000 psi. We couldn't run the logging tool, PLT. You know PLT, right?
PLT.
So 4,000 psi, we are unable because there is much force against this tool. You know, pressure equals force divided by area. So if the area is small, in this case, the force will be high, right? So the pressure is high and the force is. So if you increase the force, then you can run easier. But the area was small, high pressure was high, so the force was high. In this case, what happened? We bullhead 25 barrels of fresh water to the well to reduce the well pressure from 4,000 to 2,500. The well is not dead. We want the well to be alive. Why? Because we want to produce it during the PLT. You know that during PLT, the well should flow, right? In this case, we could run in hole easily, deploy the tool string after reducing the well pressure from 4,000 to 2,500. Then when we open the well, this 25 barrel of water was produced, and we continue. Right? Clear for you, my friends?
Yes.
Very nice. If you have any question, please tell me. We can stop and answer. Now let us move on to well control, introduction to well control. You know that we have the principle of our operation as an oil and gas industry work as if we have like a tiger or lion underground. What do we call this lion or tiger? We call it formation pressure, right? This formation pressure, when we reach to it, we have to like this. We catch it. Don't attack us. This is our fact from our operation. So if we go and touch or face this tiger or this lion, and it attacks us, it will kill us or not?
Yes.
Of course. So we have our aim or our principle in IWCF is to control this formation pressure or reservoir pressure. How? By using the hydrostatic pressure. So this hydrostatic pressure, what does it mean? Hydrostatic pressure, what does it mean? It is the pressure exerted on the bottom of the well by using a fluid with a certain mud weight or density at a certain true vertical depth. That's it. And I will give you the formula for hydrostatic pressure. You have API formula sheet or not, my friend? API formula sheet. This will stay with you during the exam. Please, you printed it out or not?
Not yet.
Not yet, no problem, we still have time. This will stay with you during the exam. So please, if you print it out and keep it with you together with calculator, pen and paper. That's all you have, and your passport or ID card. All of these will stay with you during the exam. So you don't need to memorize the formula, and because all of them will, you will see them and you will have them in front of you in the exam. Just you have to know how can I use them, how can I utilize this formula during the exam. So hydrostatic pressure equals true vertical depth, if you write it down please, true vertical depth times constant, which is 0.052 times mud weight in ppg. So here, if you look at here, this tank, we have this TVD from surface, you see it, from surface till here. What do we have? We have here liquid or water, and we have here, say, gas, right? So hydrostatic pressure at the bottom of this, we can call it this tank. How much does it equal? It equals the hydrostatic pressure of water plus hydrostatic pressure or oil plus hydrostatic pressure for gas, like this, right? So hydrostatic pressure for water or oil equals TVD. How much is TVD? For example, 6,000 feet here, times constant 0.052 times mud weight or density. Density for water 8.33 ppg, plus for the gas, how much is the hydrostatic pressure for the gas? We say TVD, for example, 1,000 or 2,000 feet times, we say for the gas pressure gradient 0.1 psi per foot, pressure gradient. So pressure gradient equals what? Pressure gradient 0.052 times density. We have also to know this formula. So pressure gradient equals density times 0.052. Also pressure gradient equals specific gravity times 0.433. So all of these formulae, we find them in the in the API formula sheet, which was sent to us by IWCF. So they want us to use it. That's it. We don't want to memorize such formula. So an example here, hydrostatic pressure is not dependent on the volume. You see this volume. I will just put the pointer. Yes, you see the pointer now, Mr. Muhammad. You see it?
Yes.
Very nice. Now hydrostatic pressure is not dependent on the volume, just the density of the fluid and its true vertical depth, the vertical column length, this one, right? So TVD and mud weight. As an example, at right here is shown a partially filled tank of diesel. This is diesel with a sight glass here installed on the tank on the left. You see it? This one. The level of the diesel in the sight glass, this one, indicates the level of the diesel in the tank. This one, isn't it the same? Although, sorry? Yes. Although the volumes, you see the volume here and volume here, you cannot compare. Here is too much and here is very little. Although the volumes of the side glass, this one, and tank are vastly much different. The hydrostatic that exists at the bottom of the tank is the same, right? This one and this one, the same, regardless of the volume of the fluid. We are talking about the pressure. Here, the same as the hydrostatic pressure in the tank at the same point. Here and here at the same point, the same. You see, this is what I told you. The pressure, hydrostatic pressure, equals what? TVD times 0.052 times mod weight in ppg, pounds per gallon. Right? Clear for you?
Yeah.
Very nice. So this formula is used to convert ppg, this is the ppg mod weight, to psi. Now, this formula is used to convert psi to ppg. How? We want it in ppg. Here is the formula. So you want ppg mod weight, you can take these two and put them under, yes. So ppg equals psi divided by, between brackets, not to confuse, between brackets 0.052 times TVD. Clear for you, my friend?
Yes.
Very nice. Now we have two types of depths. We have true vertical depth, like this. It is what you see the apple when it falls down from the tree to the ground. Newton, you know Newton, like this. So it is true vertical depth, and we use this for calculating the hydrostatic pressure. And we have another depth. We call it measured depth. What is measured depth? When we drill a well, it is impossible to get it 100% vertical, right? We may like this, then so long way. Instead, if I tell you where is your ear, you tell me here. This is true vertical depth. While if you tell me it is like this, it is measured depth, right? You understand it, my friend? Yeah, very nice. So this is, so true vertical depth, we use it to calculate what? The pressure. Measured depth, we use it to calculate what? The volumes, right? Very nice. You see this one. This is vertical depth, this one, and this is measured depth. Where is your ear? This is vertical depth. Where is your ear? This is measured depth. So this is vertical depth, is used for calculating the pressure. This is used for calculating what? The volumes. Excellent. So, any question till here, my friends? No, very nice. There may be here, there may be times when an estimate of hydrostatic pressure is needed. These are easy calculations that we just calculated and are dependent on the fluid in question and the vertical current height. Now produce the fluids. We have three types of fluids, my friends. We have liquid and we have gas. Liquid, what does it include? Oil and water, right? And gas, gas only. So when I tell you liquid, you will think either water or oil, right? When I tell you fluid, you will think about oil, gas, and water, right? So these. So produce fluids. We produce. What do we produce? Do we produce orange juice or lemon juice? What do we produce, Mr. Saritan? Huh? Fluids. What do these fluids include? Tell me. Excellent. So during the course of our intervention, this course, it may be necessary to estimate the hydrostatic pressure of produced fluids contained in the well. So produced gas and water are measured in gradient. I told you just now.